Thanks. Thought I just should be pop in for a short while.
Yeah, yeah.
So how are you guys doing?
Good to explain yourself. All right. Um. So, like, you've been fascinated with us. Can you let us know why you're fascinated with this particular thing?
Yeah, quite a few things. First off, as the psychology of and the way you think. Another thing is the logic you try to implement.
Yeah.
That you seems to forget the starting premise has to be correct. You can always have a logical, how do you say it in English? Do a logic layout, but unless the starting premise is wrong, the
First
conclusion will be wrong.
principles.
Yes,
Well, the first principles is the
basically.
straight line, right? That's always been our first principles.
Yeah, well, I don't think I agree, but I've asked you quite a few times about this claim of yours that all horizontals on Earth are parallel to each other, even by
Even the
distance.
ones
And you
that
never.
aren't on the Earth, like I've said, all of them. The ones in the air.
No, hang on. You're still trying to deflect for answering this question directly. And I ask you a few times. Let me give you an example. Do you actually think that the horizontal at the North Pole is parallel to a horizontal at the equator? Yes or no?
Yeah, all,
If you
all,
can't answer yes or no, I just leave.
all horizontals. Yes, we've had Betty do this. The swimming pool question, I think Betty called it.
I didn't ask what Betty said or had done. I'm asking you.
Mm-hmm.
What is your claim? Do
All,
you claim?
all,
Do you? Yes or no question, Bev. For
all, every one of them.
okay, which means going from the North Pole to the equator along the sea, that would be more or less a continuous horizontal plane, wouldn't it?
I wouldn't know. No, wouldn't know. All I'd know is that how to establish a horizontal plane,
yeah,
right? And the
yeah.
fact
Okay,
that all horizontals are
the
parallel to
sea,
the plane of the
yeah.
horizon.
So first, you say yes. You think that the horizontal at the North Pole is parallel to the horizontal at the equator.
You just put X
And
and
I
X. It
said,
doesn't
well,
really matter.
hang on, let me finish. In that respect, that means that the sea from the North Pole to the equator must be more or less like a horizontal plane. You can't have much of an elevation change because then the water would go to one side, wouldn't it?
I wouldn't know. There's
You wouldn't
tides and all
know.
sorts of stuff.
Forget tides on the average.
Within a range, I would say.
Yeah,
Within a range, yeah, you've got to have
within a range.
yeah.
Yes, that's what I mean.
Fluid
Yeah. Then I
dynamics
have
would dictate.
yeah. Then I have a question for you. Regarding Polaris. We know that Polaris is about 433 light years away.
It's just a light
Measured
in
by,
the sky to me. I wouldn't say how do you
it
know
is, but
that?
if you go and check and see how they've done the different
You
measurements.
said we know. I don't know that, so I'm
Yeah,
asking you.
okay,
How do you know
let
it?
me inform you. Yeah. Okay, let me inform you. Could you please look up Hippocrates or Gaia satellite missions?
Sorry?
Hippocrates and Gaia satellite missions. You ever heard about them?
No.
Do you know what a Cepheid star is?
No.
Okay.
Is it a light
No
in the
wonder
sky?
you think it's. Yeah, exactly. You have absolutely no idea, so you think it's just a light in the sky. Well, I don't care. The measurement shows that they're 433 light years away.
What
And if the
measurement?
horizontal, and hang on, let me finish, because I got short of time. So if the horizontal at the North Pole is parallel to the horizontal at the equator, you would have to move 7.6 light years away from the North Pole to just measure 1 single degree change of elevation angles. Please explain this based on your model.
Dude, mine. my model is just that all horizontals are parallel, right? Like
but
you
that
said,
has consequences.
basic logic supported
But
by Euclidean mathematical principles, right?
Yes. Yeah. I'm actually talking about Euclidean
Okay.
just
So
now.
how do you know that you've made a measurement of that distance then?
Oh, I've measured the elevation angle from Tromsø in Bodø and in Ålesund, which has a distance about 900 kilometers between them. And as I calculate from different distances and the change of the angles, it ends up approximate, from my calculations, about 111 kilometers between 1 degree.
So you're talking about a difference of angles
by distance from the North Pole.
Is that like the sine? Or, you obviously you can't use the law of sines, can you? You couldn't.
I don't have to.
No, I know, but in order to get
no,
your, what was it?
Hang on. No.
Billion.
Let's.
I don't know.
Yeah, let's stick to straight lines and Euclidean geometry.
Well, distances are straight line distance. That distance that you quoted, that's a straight line distance, right?
No, it's a distance of the surface of the Earth.
No, to the light in the sky. Your
that
original
is
distance,
yes.
When you said we know, and I said I don't know that, how do you know it? That distance.
By going by the science of people who has the equipment and know how to do it.
But that would be geometry, right? A distance measurement. That would particularly be geometry, except a geo is Earth, right? But you're not talking about that. You're talking about distance to a light in the sky. So you can't necessarily be using geometry because
but we know the distance to Polaris.
We don't. I don't. This is why I asked you.
I don't care. I don't care if you don't know. Bav, I don't care that you don't know. You just claim this.
No, you've
as
just
an excuse
it,
because it gives you so. No,
you've just claimed we know, and I said I don't know that. How do you know it?
To be honest, you use this claim you don't know as an excuse to get away from the problem it creates for your model.
No, literally,
it's
I don't know how you
it is as simple as that. Oh God, Gaia mission. You never heard about the Gaia mission?
No.
No. Okay. Not Hippocrates split mission.
No.
Parallax.
Heard of parallax, but parallax
you know what
of
it
the
is?
light in the sky, the distance measurement.
Parallax of the. Yes, you can. Yeah, that's simple geometry. Have you heard about the very long baseline radio interferometer?
Hang on. Again?
It has been varied, but the distance is more and more accurately being measured.
Okay.
From the Gaia machine, which is the most
measurements to be able to be had to a light in the sky, right?
It's not a light in the sky. What? Could you please stop calling it a light in the sky? You know as well as me, it's a star. We know this, but from the spectrum, from the radiation, from the electromagnetic radiation coming from the star, it's even a C5 star. You don't even know what that is. So why in the hell are you just calling it light in the sky and not listening to what information?
How you know something? You claim to know something.
I've read the scientific papers, and I understand how it has been done. I understand the mathematics they used. And now the physics of the stars, the measurement of the electromagnetic spectrum.
Physics now as well.
Spectroscopy. I know what a Cepheid star is, and I know that Polaris is a 3-star system. But anyway, so we know the distance. I don't care if you say you don't know. I don't care. But the rest of science know the distance.
But the only way of doing that is by triangulation, right? You can't do it with a square.
Yes.
You need a triangle.
No. It's yes. You're right.
No. Is it that a no or a yes? The only way you can
triangulation.
predict
Triangulation, yeah.
distances is with a triangle.
It's several, but parallax. That's the main measurement which has been done.
Okay.
But it also ties into what we know about Cepheid star. The Cepheid stars are variables.
So you mentioned
We know
like
quite-
900
astro-
kilometers?
900. What are you talking about?
You said, like, because I'm just trying to work this triangle. You measured 2 angles from 2 different places. And these
I did, yes.
Okay.
1100.
That doesn't. Yeah, but that doesn't give me the distance.
The
My
triangle.
measurement doesn't give the distance.
No.
Yeah. That's not how you measure the distance to a star.
Triangulation, right? Angles.
Parallax. Angles, yes.
Yeah, well, that's what
Angles,
I said. Like,
baseline.
parallax would be using the law of sines, right?
Yes. And you use satellites which travel far off. Yeah. Of course, it's calculations. But remember, it's not just.
So what number did you come up with then?
Which tells. Well, let me try this again. The change of elevation angles that I've got tells me nothing about the distance to Polaris, unless the surface of the Earth would be a horizontal plane. Problem then is that I would get different elevation, and the problem is I would get different.
Plane, though, right?
No.
You know that.
You know what?
That the surface of the Earth is not a horizontal plane, don't we?
Well, if you establish horizontals, would they be
parallel?
Yeah, exactly. Which means if I establish horizontals along the way from Tromsø to Ålesund, they should all be parallel.
They will be
done by the sea. Yes. Okay.
They'll be both parallel
then
to
you have
the
to explain
horizontal that you established before and the one that you're going to establish after, all the way along the way. All of the horizontals
so how do I get,
will always be parallel.
Yes. So my horizontal where I live is parallel to the horizontal in Tromsø. That's your claim.
Yeah, all of them.
Okay, fair enough. Then we could use my measurements or any other measurements of elevation angles and distance. Hang on. Mm-hmm. Elevation angles and distances. Problem is then we end up with a right angle triangle. And
where you get a right angle
using Polaris has a GP, yes. There's a place on Earth
in the sky
where you can be.
Sky, they're not on the ground.
Oh God, Dad, please don't be this ridiculous. You know exactly what it's meant. It's a position on Earth. It's a position. Hang on. No, it's a position on Earth where you at a specific time will be directly under a star.
Don't be stupid, man.
Have you been outdoors on a starry night,
yep,
Dave?
I have, and looked up as well. Yes.
Yeah. Have you seen a star being close to straight above you?
I wouldn't know. Like, there's loads of fucking lights in the sky up there, isn't there? And they move.
That's not what I asked. That's not what I asked. Yes, they do move.
There you go.
And the thing is,
so do you think
all
you
of those lights in the sky at some time? Hang on. At some time will be directly above an observer. Depends, of course, on your position on Earth. It doesn't matter. But at the North Pole, just less than a degree away from the North Pole, you will be directly under Polaris.
So not at 90.
At a specific time. It will be the line from the horizontal.
Is that the
geographic? To Polaris, straight up, will be 90 degrees.
So there's a location that's marked.
Yes.
There? Polaris.
No.
Look up.
No.
Polaris is there.
Yeah. And if We know it's a tiny. It's about a half a degree away from the rotational axis of the geographical North Pole. If you move
Oh, so
half
the
a degree
geographic, not
to the
on the
side,
geographic then.
pardon?
So if you were at the geographic, it would never be
Yeah.
above you.
No, it would be. No, it would be like half a degree away. But if I then move
Have you ever measured that?
hang on, half
Have
a
you ever
degree is
been
about
there
what?
to confirm that?
About 55.5 kilometers. So if you move 55.5 kilometers away from the North Pole and you wait
In which
as
direction?
Polaris rotates around
South, obviously.
Yes.
If you
Yeah, how
move
can
away south, yeah?
Yeah, you can't go north of north,
direction,
can you?
Which direction is south?
Any direction from the North Pole. You can't go north of north. That's quite simple.
Did you
What a
say
stupid
any
question.
direction?
From the North Pole.
Yeah.
How the only way you could go without going south would be straight
You sound
up.
like a flat earther. Are you sure you're not a flat earther?
You can't be this ignorant or pretend to be.
It does.
If you're standing in the middle of, if you're standing in the middle of the North Pole, if I take a step towards the left,
North Pole,
right,
how
back,
big is it?
it's a single point.
Oh,
okay.
Right. You're standing in the middle of it.
Yeah. So yes, I'm standing in the middle of it. I take a step to the right or the left, or forward or backwards.
Yeah.
Will I be moving south?
I wouldn't say so, but
will I be moving south?
Is that what you imagine?
If Polaris isn't at 90 degrees above you, and you have to move further away somewhere else for it to be there, are you moving north from north in order for that to be so?
South. How you
so
can't
Polaris
go north
isn't at the North Pole then.
Let me just get this right. Let me just get this right.
God.
If you're at the North Pole, you have to travel south in order to get the Polaris above you.
Yes.
On your model.
Yes. Yes.
Okay.
Yeah, that's what I was asking. Basically, you're not moving north. You have to move south to go to the north to be more direct and specific.
No, that's what I've been saying all along. Polaris is about half a degree away from the North Pole. Which means if I'm standing directly on the North Pole,
where it is 90 degrees above, you've got to go south.
Can you let me explain, please? If I'm at the North Pole, I measure the angle to Polaris. It's about 89.45 degrees. If I move to the side, south, just a tiny bit, about half a degree is about 55 kilometers. Then, since Polaris is rotating around, at a specific time, Polaris will be straight above me. It would be 90 degrees from the horizontal up to Polaris. This can't be that hard to understand.
Right, so that's a horizontal being horizontal and vertical being perpendicular.
Yes.
Right, and would that be true of everywhere at 90 degrees?
Yeah, well, no.
What shape would you make?
What shape of what?
If you were to have that 90 degree that you call if you're at the place where you imagine the light in the sky is directly above you, don't know how you'd measure that, but you were to do that. No problem. And you were to follow it. Yeah? So it constantly did that out for how long? 24 hours, so let's say?
I don't have to follow it. I just need one.
No, I was talking about to do this mental picture, right? You've got Polaris that you say isn't at the North Pole, and you're going
half a degree off.
You're going to follow it half a degree, right? So you're going to follow it at half a degree.
No, I move away from the North Pole.
No, let's just follow the GP of the north of Polaris, right? For a day.
Yeah.
What shape would we
Okay.
make?
It would be a circle.
Okay, now all of those points on that circumference of the circle would be at 90 degrees. So therefore, you would have a vertical and a horizontal.
Yes.
Right, on both sides of that circle. In fact, all the way around that circle.
No, it's 90 degrees to the local vertical.
Yeah. So that's what I'm saying.
The horizontal. Yeah.
Or at every point of that circle, you would have a right angle there, right?
Yeah. Yes.
Okay.
Yeah.
Of the light in the sky.
Yeah.
Okay. Now that circle is a traditional Euclidean circle, right?
Yeah.
So
what?
The plane of the circle, could that be considered horizontal?
Yes.
Okay. So therefore, if the plane of the circle is the horizontal, all of the 90 degrees that you've measured would be perpendicular to that circle, right?
It would.
Okay. Well, it seems like
here
we
comes
do
the
agree.
problem. No, hang on. Yeah. Oh, yeah. But no. Here comes the problem. If I then move away 111 kilometers and create a circle, and I measure the angle to Polaris from that circle using the horizontal or the vertical, doesn't matter really, I would have measured 1 degree change in elevation angle. If the horizontal at the first point would be parallel to the horizontal at my second point, 111 kilometers away, that would be more or less like a horizontal plane. Geometry tells us, but I'm measuring from this circle the angle to Polaris. The problem is geometry tells us that the angle does not, the change of the elevation angle does not in any way geometrically conforms to being on a horizontal plane. So either the height, the elevation of the Polaris has to change, or the surface has to be curved, which means the horizontal is different from the horizontal at the North Pole.
What about the problem? Could the problem be that you're imagining that you can measure a distance to a light in the sky by using an angle?
I don't have
measurement?
No. In this situation, no. In this situation, the distance to what you call light in the sky is irrelevant. It doesn't matter.
So you're saying like Nathan Oakley, right? Nathan Oakley does the same thing, but he says he just doesn't work out to the light in the sky. Pretty much like you're saying. You can't use these angle measurements to get a distance to a light in the sky.
We don't need the distance to the light in the sky.
You can't apply that.
Yeah. But here's the problem, Bev. If the Earth was so-called flat or a horizontal plane,
isn't flat, mate. Or a
no.
plane.
I know. It's for you. It's a horizontal plane with the topography and tides and waves.
The Earth is just the land that we live on. For me.
What? I don't care what it is for you.
All I say
what
is
I'm
that
asking
all
you,
horizontals are
hang
parallel by logical deduction. That all horizontals are parallel to the plane of the horizon.
But it's the starting.
You can say that all horizontals are parallel.
Is the starting premise of your logical part regarding that? Is that correct?
What?
Do you have any evidence that any horizontal established on Earth are parallel to each other?
Yeah,
by measurements.
We've done a realizing Euclid test, to show that a straight line lies within a plane.
It does, but you just done that from one single point. Have you done it for 2, 3, 4 points and compare the horizontals to one another?
Yes. Yes, that's the whole idea of the realizing Euclid test, yes.
Oh, you have. Fantastic. That means then by your measurements and claim, the Earth has to be a horizontal plane with
No, it doesn't.
topography,
No.
tides, and waves.
No, it doesn't.
No?
No, it's definitely not. The Earth is definitely not flat. It's definitely not a In fact, the realizing Euclid test didn't bring the Earth into it at all. It was just to prove that a straight line lies within a plane.
Then how can you say that all horizontals on Earth are?
That's a completely different argument. I call that one the argument. It's just that all horizontals are parallel to the plane of the horizon, and you can use parts of Euclid to show that if two lines are parallel to another line, then they will necessarily be parallel to each other. That's the way it works. That's how I can say the all horizontals are parallel. I've just got in it. Oh, shit, has the voice gone? Can you?
Basis of it has to be validated one way or the other, which obviously you haven't done.
The realizing Euclid
And that's
test. Did you just cut out then? I got it. My voice connected went red.
And yeah, I think maybe I didn't hear. If you were talking recently, I didn't hear you. But you said what I said. You said you did not take Earth into account while doing the Euclid test. Yeah. Yes. You said you did not take the shape of the Earth into account.
No, we're not bothered about the shape of the Earth. That's for crazy people, flat earthers and the like.
But that is a problem, Beth.
Why is it?
How do you validate then establishing different horizontals, but distance between them, they actually on Earth are parallel?
Shared straight line segments, mate. That's the way you do it.
It's not what I asked for.
Well, that's what we did for the realizing Euclid test. The shared straight line segment. That's the geometric principles, right?
Yeah, but it doesn't tell us anything about the local horizontals on Earth, does it?
Yeah, we used a tool that establishes a horizontal plane of reference.
Yes. Yeah. And did you make two of these?
Yeah.
A distance and compare them to one another?
Shared.
Do you use like an auto level?
I'll say it again. Shared straight line segment. Yes. I just got to go and take this some breakfast.
Yeah. How long? Yeah. And the segments how long were the segments? You still there? Hello?
He just said he'll be back in a minute.
That's okay. I've got to go anyway. So, but ask him to explain then how we measure.
You can ask him yourself.
Elevation.
You can ask him yourself.
Okay, then he has to.
Yeah, I'm not your messenger. I'm sure
But
you're quite capable of asking him yourself.
Yeah, but I don't have much time, you see.
Oh, okay, but yeah, everyone else does to do your dirty work. Fine. You carry on being obsessed with the shape of the Earth. We'll carry on laughing at you.
No, I'm not actually shape of the Earth. This ties into the claim. This turns into the claim that all horizontals on Earth.
No, it doesn't. You're one of the weirdos that thinks that if you talk about horizontals being horizontal and stuff, that makes you a flat earther. You're one of those crazy fools.
No. I'm actually what I'm doing is tying into the claim that all horizontals on Earth are parallel to each other. And how do we validate that? We could do it in several ways. We could use, like Beth says, lights in the sky.
But it doesn't involve the measure of
diverging.
does it?
Diverging verticals.
Is that?
If you want to mesh that in with people who say that the Earth is a topographical plane, and I've never heard that stated here amongst these people.
Well,
that is their view or a model even. So
I've wrote them in a comment some time back.
Well, I haven't heard that. Maybe you need to listen to what he said he's doing and what he is actually saying, and don't bring an assumption that people are affixed to some model that you imagine. So that was all.
No, that's fine. That's fine.
I'm back. Sorry about that. I had to send the missus breakfast.
Yeah. No, but then how do we check if my horizontal is parallel to your horizontal in the UK?
Well, you can know that all horizontals are parallel, right? There's no tilt to a horizontal.
From a single, are two horizontals at two different positions parallel to each other?
Yes.
Based on
yes.
Yeah, okay. If you establish them by being perpendicular to the local vertical, will they still be parallel? On Earth, I mean.
Yeah, vertical and horizontal are always perpendicular, right?
Will two horizontals at distance on Earth, being perpendicular to the local vertical, be parallel to each other?
Yeah, you just get 2 points at an equal elevation and join them by a straight line. Right? That's
not what I asked.
That's a horizontal, right? You can have a perpendicular anywhere along it, can't you?
That's not what I asked for.
Well, could you
try
show
this.
one that isn't?
Let me try
show
this
one that isn't? If you want us to say all horizontals or whatever, show us one that isn't. Then in reality, because you obviously think that they don't. So in reality, show us horizontals that aren't.
My question was, if we establish a horizontal being perpendicular to the local vertical, and you do this with distances between the horizontals, and you compare them, will they be parallel to each other? And the second question is, how can we check if this is correct or not?
Have you done that? Have you tested that?
Wouldn't the proof be geometric, right? Or presumably the proof would be geometric, right?
Yeah, it will be geometric, yes, but what we will
and horizontal
use as a base is a plumb.
Are perpendicular. We can say that, right?
Well, we know that verticals on Earth are diverged by distance.
See, again, you say you know that. I don't know that. How do you know that?
Show us one. Show me one. Show me where that happened. In reality.
2004 Switzerland geodesic vertical measurements, where not only the verticals diverge, or the plumb diverge by Earth curve, but they also diverge due to what they call gravity anomalies, close to mountains, lakes, and so on.
Is that geometric?
It is geometric, yes.
Okay. So where's the geometry to support that? If it's a geometric statement, can we see the geometry that supports that, please?
It's based on the geoid.
Based on what?
The geoid.
Not got a clue.
That's what you call it in English? Okay.
Geometry, I said.
No, it's an idealized shape of the Earth.
A what?
Which is
idealized.
Yeah. Well, I'm sorry, my English is not my first language, so sometimes it can be a bit difficult to explain. But anyway, it doesn't really matter, because if we are going to do this, we have to come up with some sort of methods.
Realizing Euclid test, mate. If you want to know if a horizontal is a straight line, right? Yeah. I mean, it may sound ridiculous, right? But a horizontal is a straight line, right? From point to point.
Yes.
All points at an
Not from
equal
point to point.
elevation.
From one point. Well, it depends on what kind of geometry you're in.
What do you mean?
If you're on a sphere or a circle or something like that,
No, a sphere.
you will have
both a
point,
sphere and a
1
circle.
point.
Both a sphere and a circle are Euclidean geometry, right?
Yeah. But
Okay,
if
so
you
the
establish
geometry won't change, then will it?
Yeah. No. And you have a tangent, and perpendicular to that tangent,
Well,
you would have a
that's
vertical.
Euclidean geometry. Yes, that is
Yeah.
Euclidean geometry.
No problem. But what happens if you have two tangents on a sphere or on a circle at distance?
What happens?
Are those two tangents parallel?
Unless they're at the other end of the diameter.
Yeah.
Then they would
So
be perpendicular, both perpendicular to the diameter, right?
Yeah.
Making them
that gives
both
us,
perpendicular to the same line. Now, can you imagine that diameter being horizontal?
the diameter being. Oh, you mean like a circle laying flat down?
No, like stood up, vertical, a circle in a vertical plane.
Yeah. Well, yeah.
And then you have the diameter being horizontal, and then you could have both of those, what you call tangents, but I'd just say they're perpendicular.
Yeah, it doesn't matter.
Right.
It's just a play of words.
So that
means
diameter can have perpendiculars, even in the center too, right? One in the center and one at each end. Any distance measured as a straight line.
We were talking. No.
Those geometric principles could apply to that very straight line, couldn't it? In reality,
you would have two.
Right?
You have two. Hang on. If you establish 2 or 3 or more tangents on this surface, on the circle or on the sphere, and the tangent would be what we would call horizontal on the circle or sphere.
No. You'd have to have the diameter being horizontal.
It doesn't matter.
What do you
It
doesn't matter? Yeah, it does, because you can't have all of the tangents to a circle being horizontal unless the circle is entirely horizontal. Then all of the tangents to that circle would also be on the horizontal, wouldn't they? Geometrically.
Put a ball.
Anyway.
Yeah. Put a ball on the floor. You have the floor is the tangent to us. The floor will be the tangent.
So let's say the floor's level, right?
Yeah.
Okay.
Of course. That's good. It's horizontal. Fair enough. We'll put the ball down. Well, the ball touches the floor. That will be the tangent. You agree?
Well, the ball's just on the floor, right? You can't just turn the floor into a tangent. But yeah, I understand the geometric principles of.
Yeah.
Right.
And the ceiling would have been, if you lift it straight up, would have been.
And as long as the ball isn't rolling, the ball isn't rolling, you could say that the floor is horizontal.
So those two tangents will be parallel. Yes, we agree upon that. The floor and the ceiling will be approximate parallel.
Well, if you put another board on top of the ball, right, then you could say that would be parallel. That would be a tangent to the ball also, wouldn't it? Because the ceiling wouldn't be a tangent to the ball, would it? You'd have to say another tangent, and then they would be connected by the diameter.
Yes, they will.
So that diameter would be vertical, right?
But then the floor and the ceiling would be tangents, which is parallel.
The ceiling wouldn't be tangent to anything, would it?
If you lift the ball straight up and you hold it against
if you just touch the
from
ball
where
on
it was
the
laying
ceiling,
on the
you
floor.
could touch the ball on the wall at the side, the window. You could touch the ball to any plane surface, right? Couldn't you?
Let me finish. So if we lift the ball then straight up and let it touch the ceiling will be a tangent, and the floor and the ceiling would be tangents which are parallel. You agree?
No, you can't. You can't state that, Because you could touch the ball on the wall and say that's a tangent.
Don't make
you wouldn't say that that's
okay. Let's do it. Okay, let's
touch your ball on it.
Let's leave the ball. Let's leave the ball on the floor. Let's keep the ball on the floor. I got a big sheet of something, and I put that on top of the ball, and make sure that this sheet of plywood or whatever is perfectly aligned with the floor. Then you would create a tangent line on top of the ball at the same time, which would be parallel to the floor. Do you agree?
Yeah. Like I said, the geometric principles just shows that they're tangent to the same diameter of the ball. So of course they would be parallel.
Yes, but here's the crutch then. If I put that ball in a corner and the ball touches the floor and two walls, then you have three different tangents which are not parallel to each other. This is a way that we could check if horizontals on Earth established by the local vertical will be parallel to each other. Don't you agree?
What, the walls won't be parallel?
No, but they will still be tangent to the ball. Which means if you put it in a corner, you have three tangents. You have the floor, you have both sides of the walls, the two different walls. If you equate this to the tangent being a horizontal established by the plumb, then we can use this to see if
well, you could call the diameter of that ball. Once that ball's not rolling anywhere, right? You could say that diameter of the ball is vertical, right?
Diameter of the ball. It could be horizontal. It could be 45 degrees.
No.
It could be any direction you want it to be.
Look, you've already got a floor. Don't start switching it now. You've got a ball on the floor. You're calling the floor a tangent. Right?
Yes.
To the ball. Yeah. Right? I'm saying if the ball isn't moving or rolling or anything, then you can say that diameter of the ball that's touching the tangent, where it's 90 degrees, that would be vertical, right?
Yes, you could say that.
So therefore, the two parallels, the horizontals that are perpendicular to that vertical, right, they are parallel.
The top and the bottom will be parallel, yes. Yeah,
exactly.
But if
can you, like Emma said earlier, can you show me somewhere where they won't be parallel?
That's not what I'm saying. If I put the ball into a corner of the room, so it touches the floor and the two walls, you have three tangents. Those three tangents are not parallel to each other.
No, but the two tangents to the vertical diameter would be parallel.
Three tangents.
What, to the diameter? The one that's touching the floor?
Yeah.
There's three tangents.
Yeah.
What, to that diameter?
Yeah, you can have three tangents. Yeah, you have one of the floor and one of each of the walls.
Right, and one at the top, right? Now those one at the top,
Now I was just talking about putting a ball into a corner.
Well, I did say that. Well, then would the walls, right, be perpendicular? Could you square that off? Would the walls be perpendicular?
The walls are perpendicular, yes. Okay. That's beside the point.
Now, are the walls perpendicular to the floor?
They are vertical on top of the floor, yes.
As well as being... so we've got... Not only do we have the tangents at either end of the diameter that's on the floor and the ceiling, right? They're parallel. And you can also say that the walls are perpendicular to both of those.
But what you forget there,
right?
Yeah. But hang on. What you forget then, Bab, is that where the ball touches the wall, the tangent moves 360 degrees around. It's not just in one direction.
It's just the ball moves 360 degrees around, right?
No, not the ball. Not the ball. If I hold the ball against the wall,
dude, yes, we know that any point touching anywhere on the ball or the circle, if it's a straight line, will be a tangent. Geometric fucking principles, man.
Yeah. 360 degrees from the all around a complete circle.
There's no more. You can't fit any more degrees into that 360, can you? You can't manufacture.
No. But no.
There's no spherical excess.
I could
can't
then
find
make
any spherical excess for that particular 360 degrees. That's the whole.
Sphericals actually we can measure spherical excess. Yes.
What, to a
That's
circle?
been done several times, but. No, not the circle, but on a sphere. I know you deny spherical triangles exist. You deny Lagrange's, Girard's,
a triangle fits within a semicircle, right?
Hang on, no.
The whole
let me
principles
finish.
of sine and cosine, tangent, right? The functions of those.
Let me ask. Yeah.
Apply
Since
to
I
the
have you here,
circle.
Bev, what does a mathematical theorem equates to?
What?
It's a mathematical theorem, mathematical proof.
It's a theorem of proof. Theorem's a theorem, right?
It equates to a proof in math.
It
in
equates
mathematics.
to a proof. Can you show me that
it's the
equation?
same as proof. A theorem in mathematics is the same as proof. So we have Girard's. Gauss-Bonnet,
like Pythagoras.
We got and we got the Lagrange's theorems of spherical excess and spherical triangles, but still you deny spherical triangles to be a fact. Why is that?
Because triangles only have 180 degrees. That's what I say.
No, they do not.
Well,
planar triangles do.
A triangle fits within a semicircle, right? And since the circle has 360 and the triangle fits within the semicircle, the triangle has 180. Now, you can't start adding degrees to that because that would mean your mathematical principles
on a curved
fail.
surface. On a curved surface, you can.
A triangle has straight lines, though. That's the principle. That's why it has 180
on the curved surface,
degrees.
But on a triangle on the surface. But you see, now you're back into denying mathematical theorems, mathematical proofs.
Well, I'm not denying Pythagoras or sine,
yes, you are,
cosine
because you're trying to define. You're trying to define a way. You're trying to define away mathematical theorems by your understanding of geometry and maths. You've narrowed it down to just one single definition.
Who has?
And that's that. Yeah, that's not right.
What down to what? You're making claims again. Please state a bit more clearly. I say that a triangle has 180 degrees. Now, that is provable in mathematics, isn't it? Yes. Yes, it is. Okay. So for somebody to say triangles have either more or less than 180 degrees, then they would have to provide that proof, because that proof then would falsify the proof that triangles have 180 degrees, wouldn't it?
No, it's two different shapes.
What, a triangle?
What's your problem? Yeah, it's two. One is a planar triangle. The other one is a spherical or hyperbolic triangle.
Please define your understanding of triangle, because, like I said, a triangle to me has straight sides.
Yeah, but I don't care what a triangle to you is, because we have a mathematical theorem, a mathematical proof.
That might be why we're getting mistaken.
We have mathematical proof.
Purposes here.
We have mathematical proof that spherical triangles have more than 180 degrees internal angles, and we have mathematical proof for hyperbolic triangles
Not
have
actually a
less than
triangle,
180
is it? You're
degrees.
just using the technical use of the word.
It's called it's called
It's just the
a
meeting
spherical
of three
or
planes.
hyperbolic triangle. Why is who has given you the authority to decide what a triangle is and is not, Bev?
Well, I did read it from Euclid. It's within the definitions of Euclid, book 1, if you want to check it up for
Yes,
yourself.
but new definition has come along later on.
Has it? Did they put it in the foundations of mathematics, or did they forget about that?
No.
I mean,
if
my
you
book
look
is a pretty
into,
old book.
but if you go into Legrande's, Girard's, Gauss-Bonnet's theorems, you will find them.
Mm-hmm. Yeah, but they're talking about planes within.
Because of course, if you only look at Euclid and only that, and regard Euclid is the only valid math and
for
geometry.
The foundations of mathematics. That's the. There's
but
nobody
it
else
doesn't matter.
that does the foundations of mathematics like Euclid.
And
since that's what we deal with, just the basics, the real simple basics, foundations.
But there are more than basics.
What about
the world is full of more than basics?
The straight line, right, is the principles, and then the triangle shows that to be true, right? With all of the things that can follow from the straight line.
Yeah, a straight line where? Rieman's geometry? There's a lot of geometry.
Straight line in reality,
where
the
a line,
shortest distance between 2 points.
It doesn't need to be the short in a gravitational field. Stronger is a straight line the shortest way.
No, we're talking about in reality, the shortest distance between
that
2
is
points
reality.
Is
that
a
is
straight
reality.
Line.
But
in reality, then the shortest distance between 2 points is a straight line.
The shortest distance, yes, but sometimes it can be hard for us to understand. But in special circumstances, what we imagine is a straight line, not being the shortest distance, doesn't need to be.
Well, you can't get any shorter than the shortest distance between 2 points, can you?
Because there's curvature of space-time.
Yeah, but still,
so you see, it's
the
not that
shortest
simple.
distance between 2 points can't get any shorter. You can't transverse that distance any shorter than the shortest distance, can you?
Yeah, in our everyday experience, yes, I agree.
Well, I can't even imagine a shorter than the shortest distance, because that sounds ridiculous. It's called the shortest distance because it literally is the shortest distance. You'd have to go to some fantasy place where you, you break your mind in order to go shorter than that.
I totally agree. It's really, really hard to wrap your head around it.
And that's the basics of mathematics, right, that we deal with.
Basic. But basics in mathematics today also include spherical and hyperbolic geometry. You can't just leave that out.
That's the basics. Where do people get taught that? Because I'm a certain age. Can you tell me where the basics are taught? That
I did that at the university.
The triangle having 180 degrees can be falsified.
Yeah. I did that at the university 50 years ago, 45 years ago.
Right, so you're of a certain age as well, then.
Pardon?
You're at a certain age as well, then. So you're saying the basics.
Oh, yes, I am.
How come the basics are only taught at university? Doesn't that seem the wrong way round? Shouldn't the basics be taught at the beginning, the foundations?
I think. Yeah. Well, I'm not. The spherical and hyperbolic geometry is quite advanced, isn't it? I mean,
you said it was basics. It can't be advanced and basics, except advanced simplicity.
Within mathematics, it's basic.
Okay, so if you've got 2 points,
not for studying it or so.
Okay, so in reality,
it's a foundation. It's a basic.
In reality, Stefan,
it's a basic.
We've got 2 points.
It's a basic foundation.
Point A and
hang
point
on.
B, and
It's
we've
a
got the
basic
shortest distance
foundation.
between the 2 points.
It's a basic foundation of spherical and hyperbolic geometry.
Okay, right. So in reality, Stefan, we've got 2 points, point A and point B. Now, the shortest distance between those 2 points in reality will be a straight line, right?
Yes, it will.
Okay, so now that's the basics that we're dealing with.
Yeah. Yes, but you could do that. Let's say on a circle, you can make 2 points.
You can just do two
And
points in reality.
draw a straight line. Hang on. Draw a straight line from one point to the other through the circle. That would be the shortest distance.
Yeah.
The distance along the circumference of the circle will be longer. You agree?
Absolutely. It has to
Between
be,
those 2 points.
Right. Okay.
Yeah. Yes.
Right. So
That
in
is
reality,
what you
Stefan,
might call
in reality,
yeah.
Stefan,
In reality, that's a fact.
Stefan,
that's a fact
Stefan,
in the reality.
Please, Stefan. In reality, we've got 2 plumb bobs, right? A distance apart. Now we're going to measure an equal elevation on those plumb bobs. We're going to hang those plumb bobs from a bridge, and we're going to say, with the water, one body of water underneath us, and we're going to say these 2 points are an equal elevation above, an equal altitude above that water, right? So these 2 points on 2 plumb bobs, an equal altitude above the water, they're at an equal height, right? So we're going to put a straight line between those 2 points.
At each point.
Yeah, we're going to put a straight line.
Point.
We're going to put a straight line between those 2 points at an equal elevation.
Yep.
Right, now that line has no slope, no tilt. It's called a horizontal. In reality.
No, it doesn't have to be a horizontal, because then you have to make sure that the line going from one side to the other is perfectly perpendicular to the plumb.
It's just the shortest distance between those 2 points.
It's a shorter distance, yes. But as we know that verticals by plumb on Earth diverge by distance. So I give you one example. I suppose you heard the argument about
that those 2 plumb lines. Are you saying that those 2 plumb lines won't be perpendicular to the shortest distance between the 2 points?
No. That's not what I'm saying. What I'm saying is that the plumbs will not be parallel. They will diverge on Earth. That's a problem.
So that's what I said. If you measure, if you have the shortest distance between those 2 points, Stefan, what are you talking about?
Hang on.
You're talking out.
Hang on.
You're talking out of 2 sides of your mouth here at the same time.
No. If you then measure the distance between the bottom part of those plumbs and the distance between the top of those 2 plumbs,
where's the top?
There will be 2 different distances. The bottom, it's towards the water, and let's say the top is 10 meters up, something like that. Doesn't matter really. The distance between the plumb lines close to the water will be shorter than the distance between the plumb lines 10 meters above.
Well, we said we just add the 2 points, right? We just add the 2 points, like let's say 5 meters, right, above the water. And we've put mark 1A and 1B. Now we're saying the shortest distance between those 2 points will be a straight line. Yeah?
Yeah, if you establish,
Okay. So what I'm asking you is, do you not assume that that straight line will be perpendicular to the plumbs?
No.
Oh.
They will not.
Oh.
Because the verticals diverge by distance on Earth.
That's...
Rails in large towing tanks is an excellent example of that. Where you have like towing tanks like the BE600, which is almost 600 meters long, and the rails are at the exact same height above the surface of the water for the whole length. And the rails curve, and they curve exactly as expected on a spherical Earth.
Okay, cool. So it could be shown within 600 meters, could it?
Yes. Even the Boulderwood in UK, where you live, the rails curve, which means that the surface of the water dam has to curve, which means any plumb, let's say both sides of a pool like that, perpendicular to the surface of the water, they would be.
Have you ever heard of the realizing
will diverge?
Test, Stefan?
Well, they will. I don't know. I don't care about Euclid test. It's not for me.
So
It's not a valid test.
Excuse me. So earlier, you asked Bev had he tested this in reality with like an auto level and what have you, and he said yes, that he had realized Euclid for himself, and it seemed important, obviously, that to you that he'd made tests himself. It wasn't just something he'd imagined or made up or read somewhere. And now, I mean, you said university 50 years ago or whatever. In all your time, have you ever done this experiment yourself to show, well, over 600 meters, it seems, that this is so that these perpendiculars diverge? Have you ever done that yourself? Have you tested it, or how could that be tested if you haven't?
Well, I've measured it like the angles
in this question. So that was you're saying a lot, but I wonder what you've done and whether you've tested any of this yourself.
I started off by explaining how I measure the elevation angle change by distance to Polaris.
Yeah, but you said you could do it. I mean, in reality, that's a long way away.
Yeah, but
600 meters. Yeah. You said 600 meters, so you should be able to set that test up yourself, or even a little bit longer. In reality,
I see. So now we're back to you have to do it yourself.
Million light years. Well, that's what you asked Bev. You said it seemed to me that it sounded like that was important that he had actually done it and wasn't just imagining.
No. The reason why I don't care that much about his test is that he said he did not take Earth into account at all.
He tested what you needed to test. He's presented you with the same test, and you said that they diverge. So you should equally be able to go, nothing to do with the Earth, but you're going to test plumb bobs and verticals and perpendiculars and horizontals. It doesn't have to have anything to do with the Earth. It's just a test that you could do.
I have tested it by measuring elevation angles change to Polaris by distance, which is
millions of miles. You said, how could you possibly know that?
I don't care. It doesn't matter. Hang on. From you. I think no.
Physically.
Hang on. It doesn't matter. It doesn't matter when doing those measurements. The elevation of Polaris doesn't matter. It's irrelevant to the measurements. You have a point which you use as a reference, and you move away from it, and you measure the elevation angles as you move away, and that tells you either the elevation of this light in the sky, as you call it, has to change.
I'm just looking for something simple, a simpler thing than that. Yeah. A simpler verification, because at some point I'm going to need to tell my daughter that the triangle isn't a triangle. I've got to tell her that and work out how to explain that the triangle isn't a triangle and how that changes. And how perpendicular isn't, how vertical isn't perpendicular, that kind of thing. Now, if you can do it over 600 meters, then you should be able to do that in a simple test. That's what I mean. Not looking, millions and millions of miles away or 1,100 kilometers away from where you are. How could you possibly verify that? I'm talking about something simple. Something simple thing in reality that we could do.
We have.
I'm just looking for something simple that I could do and try to understand that, just to understand what it is you're saying and verify that. Because I know that, what horizontals are and verticals and perpendiculars in reality.
Well, that's what I mean.
And that hasn't conformed to the story you're saying. So that's where I'm a bit lost.
But what you could do was the same as I did. You measure the angle to Polaris at different distances. It doesn't have to be 111 kilometers. It could be whatever you like. You just need to know the distance between the two observation points, or 3 or whatever. and then just calculate the distances from there. And that would tell you something.
That's what the flat earthers are doing.
Yeah.
Exactly what Nathan Oakley's been doing. We've been telling him, you can't
yeah,
do
but the
that.
problem is, yes, you can, but the problem is
you can. You said
that
you
when
can't.
you do this, hang on.
Are you saying you can measure a distance to a light in the sky now?
No, I said
Well, you can definitely measure an angle.
The distance to the light in the sky is irrelevant in these.
That's what Nathan Oakley says. That's exactly what Nathan Oakley says. Exactly.
I don't care what Nathan Oakley says. I don't give a shit what that idiot says.
Right, well, you're saying the same thing as him. That's what we're saying.
No. I'm saying it's...
You said exactly the same.
The elevation of Polaris is irrelevant when you do these measurements.
That's exactly what Nathan Oakley says. Exactly what Nathan Oakley says.
Exactly.
Yeah, so what? But it doesn't matter what the elevation of Polaris is. The problem is, if the Earth was flat, as it is according to Nathan, as you measure these angles and distances in reality, to fit that on a flat Earth, the elevation of Polaris has to change as you move and make new observations. There is absolutely no chance on a flat Earth to have a linear change of elevation by distance.
Well, yeah, we
it's
say you can do
that.
it. You can do fuck all with an angle. Look in the chat. With just an angle and no additional information, we cannot determine or conclude anything about geometric properties or relationships.
You have two angles. You have the 90 degrees at the GP. You have the elevation angle at the observer, and you have the distance from the GP to the observer. Two angles and one distance. What else do you need?
Which two angles do you have? You presumably need a triangle.
Yes. Remember, we were talking about you could be directly under a star.
That's what Nathan Oakley says too. Right? So the distance...
That's a fact.
Okay. So it's a straight line.
Sorry about that, but that's a fact.
Okay. You're imagining...
I'm not imagining anything. It's a fact.
Line from your position to the light in the sky, right?
Yeah, it's a 90-degree angle.
Now you're imagining a straight line for the other part of the angle that you're going to measure.
No,
you're measuring the angle from the light in the sky to the ground, right?
Yes, it's at some point
so
you have a star or a light in the sky.
That's one angle.
In the sky.
Yep. That's one angle where you are.
And you move. Yes.
Right. Now, where's the other angle?
You don't need it. All you need is two angles. And
no, listen.
Hang on. Let me finish.
You said you've got two angles. I've said you've just got one angle that you've measured. One. Where's the other angle?
The GP of stars is a fact.
Where's that?
I mean, you can't refute this. Yeah, it has been done millions of times.
That?
Wherever the star is, and you at a specific time.
Right.
If you don't understand this, it's going to be hopeless.
So how do you have that distance where you place your 90? Where does that come from?
Well, it's quite simple. We know the GP of Polaris quite accurately. And we know the distance from the North Pole to the equator.
What do you mean by quite accurately? You mean from what you've told us earlier, we know that it's not at 90.
At the geographic and the North Pole, no. But just move away accordingly, and you will be
right. So we know that we don't have a 90 there, right? That's one thing that we do know, right? That we don't.
Not
according to you.
Bad. No, I find it fascinating. You still can't grasp this.
I'm trying to grasp it. I'm listening to your example.
Hang on. The 89.45 degrees.
So it's not a 90.
Polaris is off. Yes, but if you move to the side.
Well, if you move to the side while you're measuring an angle.
The distance you need to at some point, you will be directly... At some point, you will be directly on the Polaris.
So you're going south to the north.
It's not that many kilometers off the rotational or the North Pole. Pardon?
It's not, according to you, it's not at 90.
Above the rotational axis of Earth, no. But if you move a tiny bit aside,
if
the
you
distance
move
you need
a tiny bit to the side,
yes, from the geographical North Pole, then Polaris at some time will be directly over your head.
That's not where you are. You're measuring an angle, remember, to the light in the sky. You're not measuring a 90, are you?
Now we were talking about GPs of stars, didn't we?
I don't know. You were.
Why do all like celestial navigational manuals have the positions of stars at specific times? Hundreds of them. If you deny that you can be directly under a star at the specific time, then this is hopeless.
You've told
Polaris being like half a degree away from being
not
90 degrees above the geographical North Pole. Doesn't matter. You just move
90.
No, you just move aside accordingly. If it's half a degree, that should be about 55 kilometers. And at a specific time, as Polaris rotates around, it will be directly over your head. And then you know where the GP of the star is.
So why do the books,
at that point, you have 90 degrees, you have the elevation angle from the observer, and you have the known distance. You have the known distance from...
Could I finish, 10th man stuff as well then? Like Nathan Oakley.
Could I finish? I haven't even started yet on the argument.
Earther, mate.
Yeah, but you know where 90 degrees is,
and I'll tell you why it's not a flat Earth argument. Because
you just keep rambling on like Nathan Oakley. You're like Nathan Oakley without a mute button.
Okay, so now we have, let's make this short. We have a 90-degree angle. We know the distance from the...
You don't have a 90-degree angle. That's what you're imagining, isn't it?
Don't you understand
According to you,
that
you
if
don't
you move
even have a
55 kilometers
across
south
a straight
of
line.
the North Pole, if you move about 55 kilometers away from the south, from the North Pole, at a specific time, as Polaris rotates around,
Stefan,
you will be directly under it.
Stefan, do you have 290 degrees at each end of that 600 meters?
What the hell are you talking about?
Do you have a 90 degree at each end of the 600 meters?
Don't run away from the GP and distance. So now you know that if you still don't understand how you can be directly under Polaris, I don't know why. But we can. You just move away about 55 kilometers from the North Pole going south.
What you're trying to say?
Because I can't finish because you're jumping all over.
600-meter line, right, from A to B.
Forget the 600-meter line, and then we move away
90 degrees at each end of that 600 meters.
Let me finish.
Stefan,
no, let me finish the Polaris.
The question. You've got a straight line.
I will. When I finish
from A to B.
I will when I finish with elevation
at each end.
Yeah. Are you running away from the Polaris now, huh? You're trying to get to another subject.
You said you had two angles and one was at 90.
90 degrees, Stefan.
Bav, if you move away about 55 kilometers from the geographical North Pole, and the Earth rotates, which means that the Polaris will rotate above your head, at a specific time, you will be directly underneath Polaris. Do you understand
this? Why is it not calculated to that then? Why are the calculations not directed by time to exactly where this 90 degrees is? Why is it 89.15 or something?
Yeah, well, it's very close to 90. So you can add in the tiny descriptions.
It makes a lot of difference. If you know that 55 kilometers away, you could be at a 90, and that all relates to time, and you know where that could be. Why does the book that you're using Why does it not relate to that instead of this other not 90?
Well, it's half a degree and it's known, so it's very.
So it's not a 90. That's the point. It's not 90 degrees then.
No,
What you're measuring to.
It's what is it? It's about 15.15 degrees off, I think. The latest measurement.
So you have your
it's almost.
You have your angle for Polaris, whatever you said that was, and then you have this 89 and near enough 90. You said, which is 89 something. Those are the two angles.
Well, yeah. Well, if you move away from the North Pole, the distance you need, you will end up being directly beneath Polaris at one time, and that should be about.
Well, but you said you won't. You said you won't. You don't have to go south to get to north.
Yeah. Yes. A tiny bit.
Go south,
to
go north.
Really.
Okay, that sounds sensible.
You have to go south from the. You have to go south from the rotational axis to be at 90 degrees below Polaris.
But you haven't done that. It's just still an imagined idea, isn't it? It's a concept.
Well, it doesn't. It doesn't really matter because a lot of people, hundreds of thousands, in fact, have made a lot of elevation angles to Polaris at different distances from different sides of the world. So so even from that, you can just calculate where it is. So that's no problem.
It does sound a lot like Nathan Oakley and Brian's logic and the triangle that they said isn't a triangle.
No, yeah. But the point is, I haven't finished
the same thing, seems to me.
Yeah, but here's the crux, and this is where Nathan misses it. Is if the Earth was flat, there's absolutely no way you can have a linear change of elevation angles by distance. It must be non-linear. Which means it does not conform to a flat Earth at all.
Yeah, the Earth's not flat, mate. We know that.
No, it's curved.
It's curves all over.
If you measure one, it curves. It's a sphere. It's quite simple.
What is?
And just this simple measurement that anyone can do tells you it's a sphere. Because there's only two options there. Either the Earth is a sphere, or the elevation of Polaris has to change.
You can't measure the elevation of Polaris, you muppet.
Elevation, exactly. But if you were on a flat Earth,
says. You
can't
use geometry to apply 90 degrees that isn't even a 90 degrees somewhere in the distance. You can't imagine that. At least I can't. The thing is, you seem to be able to.
No, you can't, but I can.
Yeah, I know it's got holes in it all over your thing. Even
no. Hang on. Yes, geometrically, I totally agree. Because the thing is, if the Earth was flat, you would end up having a right-angle triangle.
Yes,
you would have a 90.
It's not flat.
Exactly, that's my point. Because Nathan claims it is, but according to him,
then we will end up talking about your boyfriends. Then what are you doing? Are you obsessed? I suggest you go to Nathan and tell Nathan he can't do it like we have.
I don't care about Nathan. The point here is
why you're coming here. You're coming here to try and justify Nathan Oakley's fucking ridiculousness about measuring an angle.
Why the hell do you lie? No, you're lying, because what I'm telling you is that Nathan is completely wrong. Because if for his model,
go and tell Nathan. Don't come here and tell us. It's well documented that we've been to Nathan Oakley and told him he cannot do this. It's not possible to measure a distance to a light in the sky.
Yeah. The point is, Bav, that horizontal is always perpendicular to vertical. We agree on that.
Absolutely, yes.
Yes, and as we measure elevation angles to Polaris, the measurement tells us that the horizontal has to change by distance, which means horizontals on Earth's surface is not parallel to each other. Simple as that. That was the point. That was the whole point. Nathan's model does not work at all. Neither does the claim all horizontals on Earth are parallel to each other. So where does that leave us?
He describes the model you're describing.
Yeah.
And as Bev said, in reality, he had tested Euclid, realizing Euclid test for himself. And in reality, the conversations have been had with Nathan and his crew. So, that has been done. It's not an imagined thing or something that doesn't quite work. So, yeah, maybe you should go and challenge that, because you'll find it's a very similar, description that you're giving.
Yes, it just shows that the horizontals at different positions on Earth can't be parallel to each other. The geometry just doesn't work out.
What geometry?
That is the point of the whole thing.
What geometry?
Geometry, yes.
What geometry?
Okay. We have distances, we have two angles. And then we can calculate.
You don't. You only measure one angle. The other
No,
one's
you measure. You have two. You have no. Bev, in celestial navigation, this is a known fact. You have pages up and pages down of position GP of stars and their position at specific times according to GMT. This has been done for hundreds of years. Imagine if you still maintain that we can't have a GP of a star.
I'm saying by measuring one angle, you cannot place a 90 at a distance from you. Yes, that's what I say.
We know where the GP is.
How?
We know the distance from the GP to the observer. I mean,
how do you know where the GP is? How do you know that? Again, you've made another claim.
We could just go into
I don't
go into nautical almanacs.
I don't.
Well, I don't care if you don't. Then you're just arguing from ignorance.
When you were using
What's the
we
point?
in your terminology, and I'm just saying,
I'm
not
the
part
rest
of
of
that
the world
we
who knows
that you're saying, right?
Okay, let's say quite a lot of people know about this. Sailors and a lot of other people who do celestial navigation, people who do astronomy,
but not
being
not
professionals
geometers,
or
right?
amateurs.
Not geometers.
You fit this into geometry, that's no problem.
Well, a geometer would know that by measuring one angle, you can't presume to enclose the circle.
But you don't end up having you don't end up just having one angle. You have two. You have the 90 at the GP, you have the elevation angle at the observer, and you have the distance from the GP to the observer.
So you've got enough then to do your trigonometry then. That's like we say.
Yeah. Yes.
Well, why don't you?
And for the geometry, and for geometry to be linear, change of elevation angles by distance, the baseline or the it has to be curved.
Right. So rather than you saying you cannot do this geometrically, you're going to say you want to falsify geometry by measuring an angle.
No, I say you can. No. What you can do is compare the two models, a spherical Earth and a flat Earth.
No, this is exactly the problem that we have with Nathan Oakley, right? Exactly.
Let me finish.
There's no difference. Stefan, let me finish.
No,
right?
hang on,
this is the problem we have with Nathan Oakley. We say that by measuring one angle, you cannot determine anything else geometrically from that. You say that you can.
Angles.
That is falsifying geometric principles.
Two angles and this length on one side, Bev.
Did you measure the other angle?
Which angle?
The
90?
You calculated the 90. Did you say?
I didn't no.
Where does the 90 come from?
Where do you think?
Out of your arse, right? You
from geometry. From geometry. From measuring elevation angles to Polaris. For several.
You have one angle.
We have several angles. This has been. We know that. Why is Polaris about half a degree away from the geographical North Pole? How do we know that?
I don't know. How do you know that? I don't know that.
You measure. No, you measure it.
How have you measured it?
The angle to Polaris at the North
Yes.
Pole. No,
Yes.
no. I need several people to do a measurement
Right.
at the same time.
But you've just
And no
said you
distances.
made a claim about we know something. Now I said I don't know that. So the question to you is, how do you include yourself in the we, or are you removing yourself from that group? Are you saying
let's
can say we know something, but actually nobody in the room actually does know it? You're just assuming. It's just words.
Okay, I'm sorry. I'm sorry you don't know this. Okay, I'm sorry, but it's a fact. There's basically no discussion. We have people who's been going to the North Pole and measure the angle as well.
Like
so that's why they
Stefan.
No, quite a few Norwegians
you
ski
sound
to the
like
North
Nathan
Pole.
Oakley,
and
to be honest.
And they go south to go north then. Mm-hmm. Did they confirm that they had to go south to find north?
They ski to the North Pole, and how they find the earliest ones, how they figured out they were very close to the geographical North Pole was measuring the angle.
How did they know that they were at the North Pole?
Measuring the angle to Polaris.
When it wasn't 90.
Does it have to be exactly 90? And you can still figure out where to be. You keep saying it is.
That's the other angle that you imagine that you have, isn't it?
Just a short distance from the geographical North Pole, you have the GP of Polaris.
If they measured 90, they weren't at the North Pole then?
No, but they knew that Polaris was a little bit off. So they compensated for
Without going there, they knew that beforehand.
Yes.
Wow.
They said, let's go to the North Pole. And somebody said, where's that?
It's not where you think it is.
You actually think people are that stupid.
Well, that's how people verified it. They couldn't verify it until they went there to verify it. You know.
What you do is
that's what you're doing. You're saying the same thing.
You continue going south until you're measuring an angle that's not 90. Is that right?
No, you go from the North Pole. Well, forget the North Pole. Just go north until you're directly under Polaris. That's very close to the North Pole.
Right, so you go north.
You forget the North Pole.
Yeah. So if you go north until you're 90, would you go past 90 to go south a bit to get to where you imagine the North Pole to be? But I mean, that's going beyond the point of this triangle of the 90 that we're trying to do. We're trying to finish the triangle, aren't we? From measuring an angle.
To get from the geographic North Pole to the GP of Polaris, you have to move south a bit. It can't be that hard to understand.
What, to get to the North Pole, you have to go south of north. Sounds really weird, that.
Well, so you don't understand the difference between the geographical North Pole, the rotational axis of Earth, and the position of Polaris. I don't understand how you can
make another angle. That's what I don't understand.
Could I go north?
You're only measuring one angle, and then you're assuming the other angle is 90 at a distance away from you, right? But it's not. It turns out it's not even a 90.
Could I go north until I ended up at the specific time be directly beneath Polaris?
I can go north, right? Listen, wait a minute. I don't assume by going north, at some point I will find myself going south. I don't assume that.
That was not my question. My question was, can we go north until we are directly under Polaris?
I don't believe that you can go north to go south. I don't believe that. But I know flat earthers do.
Polaris is south. The GP of Polaris is south of the geographical North Pole. So what are you on about?
Okay. So again, do you assume you can go north to go south?
What do you mean? If I cross the North Pole, the geographical North Pole, of course I will start to go south again.
Okay, flat Earth. That's what flat earthers believe, right?
Exactly that.
Yeah, but you could do that on the spherical Earth as well.
I'm just telling you, I don't. I don't assume I can go north to go south, because that sounds contradictory to me. It's just
You can't go
logic.
north of
dictates
north.
you can't go south by going north.
Who the hell is talking about going? What? You can't go north of north. As soon as you pass the geographical North Pole, you start going south.
Yeah, that's
what are you on
exactly
about?
what I say. It just sounds ridiculous to me. That doesn't fit logically.
No, but that's not the point here.
That's the problem we have with flat earthers, right? Because flat earthers
I don't care about those flat earthers. I don't care about them.
But you sound like them.
My point.
That's what we're saying.
My point.
You sound like a flat earther. You can say you don't care about them, but you sound exactly like a flat earther to me.
Well, let's start again. Let me ask you this: could we be directly on the Polaris at one point?
I don't know.
Okay, then it's hopeless. Then this discussion is basically overdone. But because
it's not really geometric, that is it? I mean, you better have better geometric principles than that.
We don't know that either, do you? You know, it's not like something you've done and you know it.
No, but you have. There's
when you describe it, you said it isn't there. It's somewhere else. It's south of north. So that even stranger imagination for something you don't know.
Oh, so we don't know where Polaris is? Is that
I don't.
your claim?
I don't. You said you do, but you've never been there and haven't confirmed it. You just said that you believe it and imagine it.
Plenty of other people have confirmed it.
Yeah, and lots of people saying there's lots of things going on. You know, you don't believe everything everybody tells you, do you? That's that's on both sides of this model you keep talking about.
Well, we could use our different star. I could look up. I could just find one in the nautical almanac, which is.
You're still going to have a triangle that's just the same argument that the flat earthers are talking about with one angle.
Close to where we are.
Distance somehow. Only to find out that you are somewhere on the ocean, somewhere-ish. That's all that's for. Just to, you're just about here.
You could do it at land as well. That's no problem.
Yeah, well, you were talking about celestial navigation. But that's what it does, just to find out an approximate thing, doesn't it? Because nothing's definite about anything, by the sounds of it. But it was just, you don't know that it's, but you don't know that if you went to where you think the North Pole is, that Polaris will be at your zenith and you'd be able to measure it and confirm it.
Really weird. I think you should go and have a word with Nathan Oakley, to be honest.
Yeah, we've tried. We've tried that too.
You know, they have branches of the Flat Earth Society in Scotland, like Cambridge sort of area, and Australia. I suppose they have an American branch as well.
FES mic gone a bit strange, or is it me?
I don't know. I think he might be talking to his friends.
Saragaki will translate probably.
No, it's Scottish, that.
Is it?
Yeah.
Oh,
I've heard
it
of
sounded a
Scottish
bit.
twang.
So I thought he sounded Norwegian. We're having a little conflab.
Yeah.
What should I say now? What do you think?
Like, I can't. Like, how similar are this? Like, it's weird. The people that imagine they can measure an angle, like, they're going mad because we say you can do fuck all with just an angle. Like, it's crazy.
Yeah. And that's not a mad idea, is it? I mean, according to geometric principles, I mean, that is, isn't it? I don't know why people argue about that and say, no, you're talking rubbish.
All I can say is 10th man must be one hell of, or like, you know, he must have been one hell of a salesman when he was like, because he sold these people on this.
Was he as aggressive a salesman as Nathan, or did he have a different kind of approach?
Yeah, I don't know whether he's his worker team. He tried to be persuasive, right? But when the niceness doesn't work if it's, you know, just false. He's been 10th man have been working on the sextant thing for years.
Right.
At least 2 years, because when QE and Nathan and all of those guys were around here, and they were dealing with the QE's fallacious modus tollens, the Black Swan. That's when 10th Man had me and Brian's Logic have little private parties. Come into this Skype group. Let's have a meeting. And he was talking about his sextant thing, measuring angles, and I said that won't work. You can't do that.
You can.
Well, there you go. See, 10th Man's a good salesman. I'd say you
No,
can't.
no.
Because you just got a one
Of course
angle.
you can.
You've got a sextant.
I mean,
You've got an angle measuring device. That's all you've got.
Yes, different. You can use quite a lot of different measuring devices. I mainly use my telescope. But anyway, as we said, we have a 90 degrees to the GP.
A telescope isn't an angle measuring device.
Of course you can. Depends on your telescope. You don't know? Okay.
Go on.
So you are talking just about one angle, but the fact is we have two angles and the length of one side. And plotting those measurements shows that the Earth is spherical, which means horizontals cannot be parallel. Oh, it's as simple as that. That's the whole point about the elevation angles to stars by distance. It's a linear change, which means it changes the same amount for the same distance.
Right, and where was that measured?
Oh, it's been measured hundreds of thousands of times.
Really? What?
Yes,
what measurement
really,
has been measured? The angle.
Distances and elevation angles.
So the distance. Right?
Not just the
distances that have been measured. They're straight line distances, right?
No, they are distances along a curved surface.
But a distance measurement is a straight line distance, isn't it?
No, well, you could do it. You could convert from the distance along the surface to a straight line between the points. You could, but it doesn't help. The fact is, that the elevation angles changes in a linear fashion. And the only way they can do that is if the horizontals change by distance.
Right,
That's
so the
why I
horizontal
wanted to go.
distance, that's a straight line, right?
No, for every point you make a new elevation angle. The geometry comes out when you plot the data. The geometry comes that the horizontal at each point must be different from the in fact, 1 degree per 111 kilometers will be the difference between the local horizontals where you measure the elevation angles from.
Is that the horizontal the observer's standing on?
The local horizontal, yes.
Oh. Nathan says that.
How
I don't know
long
what
is your
Nathan
local
says.
horizontal?
It's just it could be 10 centimeters, could be a meter, doesn't matter.
Doesn't matter.
Be like
It's
a
a
mile.
local horizontal.
6 miles?
No. Well, it doesn't matter because how long a horizontal do you think you need to make a measurement of an elevation angle? In fact, you don't. In fact, you could just go by the vertical, which is one single point.
How far was your
Wow.
distance from the observer to the GP?
Oh, I have to go back and look and see if I can find it. This is many years ago.
Well, it's 111 kilometers or something like that, wasn't it?
No, but it's the distance, flying distance from southernmost point to the northern, a straight line across the surface of the Earth, is 928 kilometers. I remember that much.
Sorry, that was a big distance. You say that's a horizontal distance?
No, I said it's a distance along the surface of Earth.
Yeah, horizontal distance?
No?
No.
Did I say that?
I don't know.
I
I
said
was just trying to work
distance-
out what sort of a distance
this-
is it? A slope distance.
Distance along. Yeah, there's a distance along the surface of the Earth, the curved surface of the Earth.
Oh. A curved distance.
Yes.
See, when people hear distances, I'm pretty sure they hear of it being a straight line. Like, if you hear it, somebody says a meter, you imagine that's like a meter along a straight line, that distance, surely.
But you could always bend the meter if you have a piece of rope or something like that, which is 1 meter long. You can wrap
Yeah,
it
but
around
it wouldn't be a meter
any shape,
distance,
any
would
shape,
it? The distance between the two
and any
points.
shape you like. Any shape you like.
Yeah, but you
That's not
can't.
what you mean.
Yeah, well, you can't say that like a ball, the diameter, the circumference of the ball to be a meter. I mean, you wouldn't say, look at that meter there.
You can't measure
It's a distance
a ball.
of a meter. You wouldn't say that, though, would you?
The circumference, of course, you can measure the circumference.
Yeah, but you
to be a
wouldn't
meter.
say the circumference of the circle is a distance of a meter, would you?
So, but what's the point? It doesn't matter, does it?
Well, that's what the point is,
no.
right? The point is that when people hear distance, they hear straight line distance, don't they?
I've repeated myself several times and said distance over the surface of Earth.
Yeah.
A curved surface
like
of
over
Earth,
the
yes.
hills and valleys and, up the... You mean that sort of distance?
No,
it's distance from A to B.
Do you say in English like as the crows fly?
Yeah, the shortest
Is that
distance
like an
between
expression?
2 points, yes.
Yeah. So let's say
That's
if
a
I
straight
fly
line,
from
isn't it?
my local, yes, but it will. If I got in a plane, which I have done, flying from here to Tromsø, the plane will fly in quite a straight line, but it still will follow the curve of the Earth.
Isn't the long distance the adjacent in your triangle?
Yeah, well, the problem here is that when you plot out all these data that you
Straight
do
line,
measure,
then. Straight line, triangle. That one.
across the
That's sort
surface,
of
along the
adjacent.
surface, along a curved
No,
surface.
a straight line.
Yeah.
Yeah, that's what I
Not
was trying to get
bending
at
or
earlier. Your
curving.
right angles that you assume 90 degrees perpendicular. Yeah?
Yeah, the local horizontal at the star's GP. Yes.
Yeah.
See any problem with that?
Well, that would be tilting, wouldn't it?
No.
According to what you say, if it's not a straight line.
No. Every point on Earth has a different horizontal, perpendicular to vertical, to plumb.
Yeah, and all horizontals are parallel.
No, they're not.
Huh.
They can't be. They can't be, because if that was the case, if that was the case, the measurements by distance to a star like Polaris should come up in a non-linear
cannot measure
fashion.
a distance to a light in the sky.
It
Again,
has nothing to do with the
sound like a
light
flat
in the
earther.
sky, Bev.
You said the distance to Polaris. Is Polaris a light in the sky?
Distance from the GP. Oh, for fuck's sake, please. Now you're being dishonest. That's what I feel. You know the distance from the GP of Polaris to the observer. That's the
How
length.
do you know that?
That's the length of one side, because we have very
You're
accurate map.
only
We got
measuring
GPS
a fucking
and all the
angle.
works.
For fuck's sake.
And then you have the elevation
sound like
angle from
Nathan
the
Oakley.
observer to
You
Polaris.
sound more and more like Nathan Oakley.
No, you don't understand this. Or you deny. You
Yeah,
try
two.
to
You said you got two.
It ruins. It wrecks your claim that all horizontals are parallel. That's the problem
You
here.
must have three
trying to
angles.
avoid this fact as much as you can, because you know what the result
No, but you
will
said
show.
you got two angles and the length of one side, so you must have three angles. This angle.
No. Two angles and the length of one side, no problem.
What?
Isn't it a triangle though?
Of course, it's a triangle.
Form a triangle. Two angles, the two sides you've got from the observer to Polaris, and the one to the GP, and then it continues 90 degrees up to Polaris. You said.
Yeah, you can
So that's
complete a
triangle.
triangle, can't you, Nathan?
Yeah.
The GP.
Yeah. So
the
that's
GP,
what I mean. You've got three angles and the length of one side. You can solve for the rest of the triangle.
Yeah, you can.
Yeah, that's right, Nathan.
But the thing is, but the thing is when you plot in the distances and the angles
And not the
for the
distances.
GP, yeah, the distances and the corresponding change of elevation angle, geometry forces you to end up with a curved surface. Otherwise,
what?
you will end up having
Geometry
a right angle
does
triangle.
no such thing, Stefan. Does
good
no
stuff.
Can't have a curved
such
triangle, can you?
thing.
You don't understand it, then.
Yeah, well, we do
Basically,
this.
You don't understand the geometry. Oh God.
I'm trying to understand what you're saying and try to piece it together from the image you're painting.
Yeah.
And it doesn't seem to.
There's no
Makes
way that
sense.
geometry forces me to curve a straight line. It just doesn't happen. There's no such thing. There's no geometric principle, Stefan. No.
It does, Bev, to have a linear change of elevation angle by distance.
Where does it say that in celestial navigation? Bend one of the sides of the triangle.
When what you have to do is either, if it's flat Earth, then you can calculate.
The Earth's not
then you
flat,
will end up
Stefan.
with
No, they don't do that. They give you a sextant.
That.
You give you a sextant. You measure an angle. They don't talk about the shape of the Earth. They just give you a sextant and you measure an angle.
Yep.
No, it's got nothing to do with shape. And then how does that triangle? How does that triangle become curved? Does it say so somewhere that you should curve one side?
Not in celestial, but what you can do is you have the elevation angle.
Stick to that
and
600
you have
meters, Stefan. Oh, yeah, I would.
and
That's what I was
and
asking.
much
Something we could
easier,
actually get hold of.
Yeah.
We can go down the road and do it. We haven't got to look at millions of miles away and somewhere that isn't there. You said 90 degrees, but it isn't 90 degrees unless you go south of north and all that. Because that's why I asked in the beginning. You said 600 meters it could be seen. So that's what I was talking about, realizing your test for yourself in an environment that was within reality that you could actually do yourself and we could replicate and go, okay, that's what he means. We found it too.
Yeah, but if as we were talking about Polaris, if you do measurements and you plot it out, there's only two options. Either the light in the sky, as you call it, have to change elevation.
Wait a minute. Can you go with, you can do fuck all with an angle? Like, is that an option?
Or the baseline that has to curve.
No. You can just say you
Two
cannot
angles
do that by measuring an angle. Can't you?
Two angles and the distance, Beth.
No.
Two angles and the distance.
Only measure an angle. The rest is imagined. All of it. And you can't assume that geometry tells you that straight lines must curve from measuring an angle.
You have two angles. You got 190. You got the elevation angle from the observer.
You don't
have the
have a
distance
90.
from the
You
GP.
don't have a 90, right?
Of course you do.
How?
It's just you denying the fact that like nautical almanacs and stuff like that.
That's a book. Does that book have a 90 for you?
It does.
Okay.
It tells you a lot of different stars and their GP at a specific time.
Did you ever do the trig for that triangle you imagine?
Yes.
So how far away is the light in the sky? You know, the actual altitude of it.
Of Polaris. It depends on which model you use. If you use a flat Earth model, it should be what?
How many
there's
different
a flat
models of
number one.
trig are there?
It's at 45 degrees. That's 5,000 kilometers from the North Pole for the GP. And if it's a flat
the
Earth,
altitude of Polaris, then is it not?
No, but if it's a flat Earth, then the elevation of Polaris would be 5,000 kilometers.
No, it's
But as
not
you
about
move
flat
away,
Earth
get
or
closer,
anything. This
do
is
the
just
same.
about a triangle you imagine.
I said in a flat Earth model.
Triangles have nothing to do with the model of the Earth. It's just a triangle, geometric.
Yes, it does.
What's that in miles? So what's that kilometers in miles? Is that 2,700? Is that what it is?
Divide by 1.608.
Yeah, if you know the distance from the North Pole to the equator, you just half it.
Yeah, but the distance from the observer to the GP with a 45-degree angle. I've heard it in miles, but not in kilometers. I was just trying to confirm whether it was the same as what I'd heard in miles.
Well, it's from the North Pole to the equator is 10,000 kilometers. So halfway is 5,000 kilometers. So if there was a flat surface, then we could use the distance from the GP and the angle, and then
Well, I've heard 2,700 miles with a 45-degree angle. That's what but you said kilometers. That was all I was just wondering, whether it was the same as I'd heard before.
Yeah.
Because that's what Nathan told me. That's what Brian's logic told me. Exactly that. Exactly what you're saying.
Yeah. The problem for them is that if you move closer or further away and make a new elevation angle measured in reality, and you add on and you use the new distance, the elevation of Polaris must change. That's why the flat Earth model doesn't work at all.
Flat Earth model doesn't
Where
work.
does it say that?
It's not flat, for fuck's sake.
No, I was talking about Nathan's flat Earth model, not yours.
Yeah,
but the thing is,
you've still got a triangle. Whoever it is talking, you've still got a triangle.
Yes, you do. But the thing is,
with two angles and the length of one side. In fact, three angles and the length of one side if you have two. So It should be solvable in any model, any paradigm at all. That's the thing.
So if you have the 90 and you have the distance, and then you plot out the angles measured in reality, the base curve baseline has to curve to have the exact same distance on the ground between every single angle.
So you don't have a
It doesn't
triangle.
say that. Yeah.
Well,
Where does it say in the Celestial Navigation Manual to assume that the adjacent is curved?
That's an oxymoron. There is no such thing.
I was just talking about geometry.
Yeah, but
there's no such thing as a curved side to a triangle. Triangles have
I
straight
think I don't
sides.
know enough. I'll leave you to the geometers because I don't obviously understand this at all.
It's quite simple. If you use the data that you have and try to plot it out, that you only have two options. Either the
Either
baseline
triangle
is curving,
or not a triangle.
Yeah, let's just start with the triangle, a standard basic right angle triangle. And as you move along, and as you move along and measure elevation angles, for every 111 kilometers, you get 1 degree in change of the elevation angle. That is not possible.
Still, triangles have straight sides.
Yeah, that's not possible in a right angle triangle, is it?
So you don't have a triangle now.
No. I said let's start with the basic right angle triangle, and let's use the distance from the North Pole and the corresponding elevation angles measured. If you move along with this straight line, the position, the elevation of Polaris has to change as you go along, or the baseline has to curve to have a linear change of elevation angles by distance. There's no other way.
So either you don't have a triangle or the imaginary right angle is imaginary, and that's why it doesn't work.
Well, we know we have a 90 degree at the GP. We know the distance and we know the elevation angles.
We don't know that. Like, what are you talking about?
I don't give a shit about what you know or don't know.
Well, you keep involving me whenever I hear we. I'm part of that, right? Or
us who has studied it a bit and done a bit of astronomy and things like that.
Okay.
We know it's like that.
You can't falsify geometry through astronomy, though, right?
Exactly.
Definitely not through measuring an angle, because an angle obviously is geometric, so that would be a stolen concept fallacy to imagine you can do that.
No, but you're absolutely right, Beth. We cannot falsify geometry. That's a very good point.
So then we can go with, you can do fuck all with an angle then, right? That's a geometric statement.
2 angles and the distance.
Just one angle.
2 angles and the distance. Why do you keep going back to one angle? We have 2 angles and the distance from the GP.
Not with a sextant, you only have one angle.
I don't care about the celestial navigation just now. I'm just doing some geometry. We know the distance from the North Pole to the equator.
Do we know that? I don't.
You don't know the distance from the North Pole to the equator?
No, I do not know it.
Okay.
Do you?
To be honest, I can't be bothered anymore.
Can you tell me how you know it?
You don't know that. And it's just an excuse to get away from all the problems, geometry and
talking
and
about
measurements
knowing
in
knowledge. Stefan. How do you
in
know
reality
it?
does to your model? So I'm sorry about I just can't be. You lights in the sky. We don't know the distance from the North Pole to the equator. We don't know shit.
Well, can you explain how you know it? Can you explain how you know the distance?
I can't be bothered. If you're so ignorant about how this is done over the years, I'm sorry, I can't be bothered anymore. And this is one of the reasons and that's just one of the reasons it's taken me such a long time to even bother to get into this Discord, because there's so much denial
Because you
invoking,
have to
I don't
back
know
your
this and
claims.
I don't
Oh,
know that.
that sucks.
So
Having to
I'm
back
sorry,
your
boys.
claim.
Yeah, no, but you can continue living in your strange world and let the rest of the world
You
go
can
on.
just explain
So,
how you imagine that you know this distance. That'd be nice.
no, I can't be bothered. You look it up yourself.
Oh, okay.
Try to
Well,
gain
then
some
you fight
knowledge.
on your own.
And don't ask
Enjoy your
me.
Sounds like
Paracosm.
Nathan Oakley again. Are you all right, Nathan? You're getting good at doing voices.
Yeah, lights in the sky. It's just so fucking laughable. I can't be bothered anymore. Lights in the sky. Do you know what electromagnetic spectrum is, Bev?
Oh,
Do you know how we can measure?
What's that got to do with an angle, Stefan?
Yeah, where is the
Sex-
geometry
It's
of the
got to do.
Definitely
electromagnetic
not.
It's what it's
spectrum?
got to
Sextants don't
do.
measure that, do they?
No, what it's got to do with it? You claiming stars are just a light in the sky.
Yeah, I'm
Yeah,
claiming
you
you
claiming
just
a
measure
distance.
one angle,
Quite
Stefan.
simple. So
One
you
angle.
boys have a good time and enjoy your strange kind of way of looking at the world. And
No, it's great. It's great you came. I mean,
Yeah,
it's great
thanks.
to hear you, and and to have a conversation. That's what it's about.
yeah,
You know,
yeah. I mean,
and
but I mean,
you know,
it's impossible to have a conversation when I don't know this, I don't know that.
Well,
yeah,
you,
but
Really
you're
basic.
saying that's what
Really
it is.
basic
That's all. It's
stuff.
just a question about what you do know, and what could be verified. Because at some point, for instance, I'd have to tell my daughter that isn't so. Triangle isn't a triangle at this
It
point,
just
or whatever.
as
So
I told you.
that's important, really, to
Yeah.
try and
Just tell
understand.
her the different types of triangles. It's as simple as that.
Yeah, but I thought you knew. That's why. That's why to ask how you know that's the question, isn't it?
How I know different types of
How,
triangles?
how you know that a triangle has more than 180 degrees, and having one that isn't will falsify that a
Yeah,
triangle
well,
does have 180
you
degrees,
could read
or
up
where
or
Polaris
yeah,
is, or those kind of questions. That's all. It's just
yeah,
just an inquiry.
yeah,
It's not. It's not a battle, really. Just an inquiry about what is known and what's not known. That's all.
yeah. It's like then you can read up on Legendre, Girard's, Gauss-Bonnet theorems, or other theorems regarding spherical and hyperbolic geometry.
Yeah, but you can't
You
beat
could
somebody
start.
coming and talking about it, really, and from their experience and what they know, and sharing that kind of stuff. That's always valuable.
Yeah, and you can read up on it and
Distance
study
is
how it's.
Euclidean, though.
Yeah. I mean, and there's a lot of stuff that one needs to wrap one's head around to understand how things work. The less you know, the easier it is to deny and end up with wrong conclusions.
You're in a prime position here to expand our knowledge by sharing how we can know the distance to the GP of Polaris. That's all we're asking.
Well, the measurement we know the distance from the North Pole to the equator.
How?
Yeah, but several. I mean, it's all from using the lights in the sky to measurements over land. Simple thing like fiber optic cables from the northern Norway to Svalbard. I mean, and you know the distance between them and so on. You can go further north. There's a lot of the submarines which has been travel under the Arctic ice using sonars and stuff. There's plenty of different measurements confirming the distance from the North Pole to the equator. And today with GPS as well. A VLBI, very long-based radio interferometry, tells us a hell of a lot about the shape and the movement of the Earth. There is so much.
So can you show us any direct measurements done from the equator to the North Pole?
You mean like stretching a string from the North Pole and up?
An actual direct measurement, however you imagine that.
Well, we know the distances across land from the equator to way up north. So we got most of the distance, and then it's It's not that very far from Svalbard or the north tip of Greenland to the North Pole. I mean, those distances has been measured in many ways. So I can't see.
Straight
can
line
you show us?
distances, right? Straight lines.
Pardon?
Straight line distances.
Oh, across land.
Yeah.
So yes, the distances are known.
Straight line distances.
Distances across the curved surface.
No, the straight line distances across the
Yeah,
line.
yeah, straight. Yeah. And from that, of course, you could draw a straight measure it, have a straight line across the curved surface from the equator to the North Pole.
Did you say straight line across a curved surface? Did you not realize the contradiction, the oxymoron you just spoke out loud?
I do, but if you look at from the top down, it looks like a straight line. Okay.
I think he means a horizontal line that cuts through the hills and the valleys, right?
Oh no.
No. Ooh.
No. That's not how you measure distances the surface of the Earth.
That's weird.
Yeah, because
What do you
you're
mean?
not measuring
Have
the
you ever
short.
done?
You're not measuring the shortest distance from the equator to the North Pole. What you do, you measure the distance over the surface of the Earth.
Yeah, and you said that's not the shortest distance, but have you ever done orienteering?
Yes.
And you use
a
two
few-
scale maps, right? Where the measurements are
Oh, yes,
actually
I know.
done in reality. To scale, like 1-to-1 done in reality, scaled down to fit on a piece of paper.
Yeah, I know. I spent some
Yeah,
years
those are
in
horizontal
the army.
distances.
I spent some time in the army as an intelligence officer in a recon unit, and we used very detailed maps. So yes, I know.
Yeah, those are horizontal distances. And those contour lines you see on those very same maps, those are, this on the same horizontal.
On a map, yes.
Yes, exactly. Two scale maps
on
measured
map,
in reality. Those are the shortest distances from A to B, measured and plotted on the maps. Measured
are
on
you
land.
sure about that? It depends on what kind of type of maps you're using.
Two scale maps.
Yeah, most maps are to scale, but some has just squares. Some has different grid systems. Yeah, and different grid systems as well. So, but anyway, I have to go, boys. Sorry.
Oh, that's too bad.
Yeah. It's been nice talking to you. So I might be back sometime. Who knows?
Cool. It's Model Affliction Monday tonight. Go and have a word with Nathan as well. He needs a bit of help. 2:00.
I can't. I just can't stand Nathan. He's a fucking idiot.
Well, you go and tell him. Go and tell him that he can't do the things that he's imagining to do. But it's the same as what you're doing. Just for your information.
No. I've mentioned it to him in the comments quite a few times, but you know what he's like. So
yeah, you'll have to go in and tell him because people don't know. He's gaining a lot of people. He's fooling a lot of people.
He does need to hear. He does need. People do need to hear people questioning that and different points of view. So, it would be good if you could just, speak to what you know and see how that compares or not. It'd be good for people to hear. That's the thing. That's what I meant about you coming over and hearing your voice rather than reading you in the text somewhere. You can kind of put a bit more reality to it, and that's what's nice. So that's what I mean. It's nice for you to come, and it'd certainly be good to hear you talking to Nathan about it. And see whether your ideas differ with his or not, really, because they sound very similar. That's all, So, he doesn't read his chat very often, and his mods, kick people out if they don't keep to the narrative. So, I look forward to hearing you talk to him. That would be brilliant.
Yeah, his and my take on this is completely different. He thinks the Earth is flat, and all measurements shows that it's not. So.
He's imagining the same triangle as you, though. That's the only difference.
No,
you imagine that the geometry. You imagine that the geometry tells you the straight line curves, and he imagines he can
Yeah.
He imagines he
Let
can
me
make
finish
an
off.
entire triangle. By measuring an angle, that's the only difference.
Hang on. Let me finish off. Make a straight line, and for every centimeters, change the angle for a line by the same amount, and see if they are parallel or they diverge or converge.
See if what are
That would tell
parallel.
you the line.
All of the
If you have a straight line,
perpendiculars to a straight line.
if you have a straight baseline, okay, and let's say every 5 centimeters, you start off with creating an angle of, let's say, 10 degrees. Then you go another 5 centimeters along the line, and you add another 10 degrees to it, and continue on and see if it hits the same point.
See if what hits the
parallel
same point.
lines parallel lines do not converge. That's the definition.
Yes. So as you move along that line to hit the same point, the light in the sky, the angles has to change by distance, but in reality they don't. So just a simple example of how this works. But sorry, I have to go. Dog is
Are you
shouting
not
and
part of a paracosm where the angle changes by a degree per x distance? Is that not part of your paracosm?
Well, it does in reality. We know that.
You
1 degree
literally
per
just said that
kilometers.
it doesn't do that. You literally said it doesn't happen. But you're just contradicting yourself. It's hard to follow you. That's all.
Not if you have a straight baseline that you do the angles from. It won't. If you have a curved one, you can get it. Bye, boys.
All right, see you later. Thanks for popping in. 2 hours, 11 minutes.
You know, I didn't mean to butt in, but I had to.
Yeah. Well, I don't know. Like, they get like Nathan Oakley. There's a point that you can't get beyond because they're fantasizing shit. They come with just an angle, but like they've absolutely, like Betty, absolutely, that they think there's a 90 somewhere where they're not, that they can use.
Yeah, and then once they curve the straight line, not only did they, explode the logic, but they also lost the right angle at the same time.
Yeah.
They don't see that, of course.
Yeah, that's why the A to B. He doesn't have a perpendicular at A or B.
He didn't manage to link the fact that the maps are actually done like that in reality. A to B, shortest distance, plotted right on the map. He agreed with it, but he couldn't make the link from that to what he was talking about.
Wow.
If you had a giant 1 mile long spirit level,
imagine LIGO, right? It's 2 miles, isn't it?
Yeah, if you were to put a bubble level on like the intersection of LIGO, that would be level. If you were to walk down the arm and place it on top of that, I would say it would not be level. That would be another good.
So you say at the split point, that's where it's level on both arms?
Yeah, I'm pretty sure that's where they leveled it.
And what are the arms? What are the arms? If the center is level, how do you envision?
No, he said no, not the center. The apex where they both meet.
Oh, the apex.
Yeah, it's different.
So,
yeah,
it's changed.
How do you envision the end of the arms then? The other two ends.
They're just gonna go straight, and this is in the engineering.
The end of the arms. At the end, you have the apex, and you have two arms running along, right?
Yeah.
How are they? Are they in the same level as the apex, or how do you envision them? Higher, lower?
So at the ends of the arm, they had to pour more concrete because it was at a higher elevation.
It's not what I asked you. It's not what I asked you. When the job was done, you have your apex, it's level.
Mm-hmm.
Either arm, how are they in relation to the apex?
They're flat. They're straight. They're straight.
Yeah.
Are they also
Straight
level?
No, they are. They at each spot they are not level. They like if you put a bubble level on the apex and you started moving down the arm, it would get off and more off level.
How? Towards the up or towards the down?
With the bubble level, it would either go left or right.
No, hold on a second. You have a level at the apex, and you have two arms running, and I'm asking. You say they're not level at the ends. So I'm asking you, are they lower than the apex or higher than the apex?
They have a higher elevation than the apex.
So they're higher than. Wow.
No, so the horizontal raises in elevation for you. No, you said it would be higher.
Hold on. The horizontal plane that was established at the apex will diverge from the surface of the earth. The horizontal plane stays straight, but the level of water starts diverging from the straightness.
What? How do you envision that? You envision level water diverging from straightness?
Yes, I do.
Wow.
How is that possible?
Because level is a curve. And water is level.
That's my model dictates, right?
No,
that's
absolutely. That's but as I was saying, like, if we go back to the straight line test, you would be able to see which one's true. If water is curved, then there will be an angle. If level water is curved, there will be an angle between B, A, and C. If water level is straight, then all of them will be collinear. It's a test.
I don't think there's any possibility of reaching you, bro. I just don't think so.
If we do the test, that would reach me.
At what point is vertical not perpendicular to horizontal?
It always is. Every vertical is perpendicular to its horizontal.
To its horizontal. And
yes.
What is a horizontal?
It's 90 degrees from its vertical, and vertical is defined from the plumb bob. I wonder if I could do it, because over a short distance, you might be able to use the Autolite app and a water level.
I mean, he obviously doesn't understand what level means.
You don't understand. Hold on.
It's not my problem if you don't want to learn. You're just on your own.
I can guarantee you there will be a hump in the middle. If you side across from one side to the other,
just take my word for it, bro.
Oh, don't take my word for it. Do it. I can guarantee you there will be a hump in the middle. There will be.
I can guarantee
there will be a hump in the middle.
There will be.
I can guarantee you there will be a hump in the middle.
Go and speak to anyone. Go up to someone that you know and just say, "Here, mate, is level horizontal?"
Yeah.
And see what you say.
Horizontal, of course, level's horizontal.
Well, there you go then.
With level, especially when you do it on a small scale. Okay, if you're talking about the water level, the horizontal plane that a water level establishes is in the middle of the water level.
You would have to understand what a line is.
You don't understand.
I mean, he obviously doesn't understand what level means.
It's not my problem if you don't want to learn.
Hold on.
You're just on your own.
Begging for your model to be real.
You would have to understand what a line is.
No, that's fine. That's fine.
So logically it follows then that all perpendiculars to that line
You don't understand.
are parallel to each other.
Yes, I agree.
It also then follows that that line cannot be a curved line or change angle anywhere along the line.
That line, yes. So this straight line we are using cannot bend because it's straight. I agree. That line, yes. So this straight line we are using cannot bend because it's straight. I agree. This straight line we are using cannot bend because it's straight. I agree.
I mean, he obviously doesn't understand what level means.
You would have to understand what a line is.
You don't understand.
You might be able to use the Autolite map and a water level.
No reason, no logic, no wisdom, no worries.
You don't understand.
You're just on your own.
Begging for your model to be real.
No reason, no logic, no answers to questions.
You don't understand.
You're just on your own.
Begging for your model to be real.
You know what we call a vertical change? You know when we measure a vertical change.
Yeah, it's an elevation change.
Yeah, a vertical measurement in the vertical.
Yeah, because it's a good approximation of the short distance.
So you're saying that horizontal being straight would get a measurement from the... Oh, wait a minute. You use a tool called a level that establishes a horizontal, and then from that horizontal you measure a vertical change, don't you?
I'm saying that
you do though, don't you? Right? Do you understand that? Right? You use a tool called a level that establishes a horizontal, and you measure a vertical change from that horizontal. And what do we call that vertical change again?
Elevation change. That's not what
a reference to the horizontal, obviously.
But I'm in reality, like this is why I'm thinking of actually doing this test. In reality, specifically say that horizontal is actually not a plane. Your misunderstanding of my model is not my problem. It's up to you to understand it.
You don't understand. Hold on.
You don't understand.
I mean, he obviously doesn't understand what level means.
It's not my problem if you don't want to learn. You're just on your own.
I have no problem with you all using a water level to establish a horizontal plane. It will be tangent to the curve of the earth. They would maintain the same elevation. But remember, levels occur. So then is a vertical angle just a right angle? Grab a water level, that same water level test, and sight across it. That's it. Anything that is 90 degrees from that plane will be parallel to the vertical that you established at that point. Whenever y'all ask me about surveying, I say, yeah, I'm not an expert. I defer to the experts.
I know, we'll carry on, you carry on, but I don't think it's... I mean, he obviously doesn't understand what level means. I mean, he obviously doesn't understand what level means.
You don't understand.
Hold on. You don't understand.
It's not my problem if you don't want to learn. You're just on your own.
We don't use proof in reality, that's pseudoscience. Or you can use it for math and logic. I don't claim to know anything about surveying.
Have you ever held a water level?
Have you ever held a water level?
Have I held a water level, the tool?
Yeah.
No, but it's a pretty simple concept.
Say, they're even so bold over there, you guys. They believe horizontals are parallel.
Yeah.
Have you ever heard of proof before? Like real
proof doesn't exist in reality. It only exists in math and pure physics.
With your picture, then. Thank you.
No. I'm not trying to prove anything.
Hold on.
No,
I'm showing you evidence that the Earth is a globe.
Prove stuff.
No, I'm bringing evidence that the Earth is a globe.
Hold on.
Why would I try to prove something? That's pseudoscience. We don't use proof in reality. That's pseudoscience. That's pseudoscience.
You don't understand.
Hold on. You don't understand.
You don't understand.
I mean, he obviously doesn't understand what level means.
It's not my problem if you don't want to learn. You're just on your own.
My God.
22 years old. You're on the fucking internet talking to people about
No reason,
begging for your model to be
no
real.
wisdom, no worries.
It's bizarre.
You're just on your own.
begging for your model to be real.
No reason, no logic, no answers to questions.
You don't understand.
You're just on your own.
Begging for your model to be real.
He thinks the zero pressure state in the water is an arc instead of a straight line.
Yeah.
I'm not laughing at Tom. I'm laughing at the theoretical conversation. Hey, there's some people who think level is horizontal and they want you all to talk about. And also, yeah, parallel and vertical being 90 degrees from one another. And in math, typically when you establish a horizontal plane, in math, yeah, it's just one horizontal.
They just go to reality to describe something other than